So today's lesson we're going to learn about complex numbers, and this will be kind of strange for a lot of people, complex numbers. So, but to solve this equation we need to learn how to deal with them because they can come up, and they even come up with the electronics equations. We'll see an application here. So, if you're taking notes, Cornell notes, you're welcome to write down the essential question real quick. Students will be able to perform mathematical operations on complex numbers. Complex. Sounds like they're complicated or something, like they're more sophisticated. Actually, they're not terribly sophisticated. They just have certain rules that you have to abide by in order to deal with them. So we're going to learn about those rules. And so that's our essential question. How do you perform operations? Or like, for example, we're going to want to know how to add these, subtract them, multiply them, and divide them. And it's just a few short rules, but we have to deal with that. So let's find out here. This is kind of a historical question. Not all quadratic equations have real number solutions. Real numbers are the numbers that you've been dealing with most of your life. The real numbers include things like fractions, which are the rational numbers. Real numbers include integers. You know, when we're talking about real numbers, that includes a lot of numbers that you've dealt with already. And so the real numbers, they're numbers like this, negative 17, that's an integer. Fractions, it includes all the fractions, 14 thirds, for example. It includes 0. It includes numbers that repeat, like one third is 0.333 repeating, right? So it includes those kind of numbers. It even includes pi, which is this number 3.14159 that goes on. And so real numbers include a whole lot of different types of numbers here. However, this equation does not give us a real number solution. It gives us a complex number. And so we're looking for a number that's multiplied by itself that gives us negative 1. If you try this in the real numbers, you can't find any. 1 times 1 is actually equal to positive 1. And negative 1 times a negative 1 is also equal to a positive 1. And those are the only two real number solutions that even get close to this solution over here. So we're looking for a number that's squared but gives us negative 1. And if you think about that for a moment, you're going to say, well, that's impossible. And it is. It's impossible with real numbers. But we could use fake numbers. Oh, not really. They're not really fake. It just requires a new number, and mathematicians were kind of wondering, well, what we have to make a new number that will make this happen, because this can happen. I mean, not all parabolas cross the x-axis. It's quite, when you draw your parabola, there's a parabola. It does not cross the x-axis. And so it has no real solutions, but there is a parabola here. So what's the deal going on here? So this scenario comes up. So mathematicians had to create a new number, and that's what this section is about. It's about a complex number, and a complex number has two parts to it. It has a real part and an imaginary part. So it's a combination, and that's why it's a complex number, because it has two parts to it. It has an imaginary unit part, and it's going to have a real part. So what is this imaginary unit? Well, it says that this little bitty I is equal to the square root of negative 1. And here's the other thing you need to remember when you're dealing with complex numbers. I squared is equal to negative 1. So if you could remember those two things, complex numbers won't be difficult at all. Like, let me just give you a few quick examples. Let's say we're trying to find, let's say we have x squared is equal to negative 16. Now, what we'd have to do is take the square root on both sides, and we take the square root over here. So one thing that we're allowed to do is to do some operations here. We can use properties of square roots, but we could rewrite this as the square root of negative 1 times the square root of 16. Okay? Well, and then also, since we're solving for x, we need to have a plus or minus involved. So we should write a plus or minus right here, and then equals x. Okay, but the square root of 16, we all know the square root of 16 is 4. Okay, so we get plus or minus. And now what are we saying this thingy is? We're saying that I is equal to the square root of negative 1. So we just simply put an I there. And it may seem kind of silly. Okay, so now we replace something with a letter. Although this letter is not a variable like x. I is this special letter that we use. It's equal to the square root of negative 1. And it's what we call the imaginary unit. The imaginary unit. Now, I'm not sure imaginary unit is the correct word that we should be using in mathematics, because imaginary suggests that it's invisible or it's not real. And it's real in a sense, but it's just not a real number. It's the real numbers that we're considering were those numbers I was talking about just a few moments ago. So this will be a strange idea to deal with. Okay, so what I'm going to do is start playing around with this imaginary unit. There's, like I said, there's two things we need to memorize. This one, I squared is equal to negative 1, and I is equal to the square root of negative 1. Now, when dealing with complex numbers, these are basically the only two things you need to remember. Everything else is kind of the same. Okay, so let's take a look at this. We have a property of imaginary numbers or complex numbers, and I just kind of showed you this before. This you can think of as the square root of negative 1 times the square root of r. Well, we just found out that the square root of negative 1 is actually I, so we could write I times the square root of r. And so that's all we're saying about this first property. You can immediately write it like that. And we usually like to write the I in front of the square root symbol, although sometimes you might see it out here. Okay, the only reason why we don't like it out here is because it almost looks like that the I is inside the square root when it's not. The I should not be inside the square root anymore. It should be on the outside. So sometimes we'll write the I in front of the square root symbol. Okay, well, let's look at some other properties. Here's another one. This one is saying, look, if you square this right here, you get negative r. Maybe we should see the sequence of steps for that. And I'll try to do that here. I times the square root of r squared. Well, that would be I times the square root of r times I times the square root of r, right? But if we rearrange these terms, these two can combine to multiply to give us I squared. And then these two can rearrange to give us the square root of r times r. But of course, r times r is simply the square root of r squared. And then I squared, we just found out from this previous slide that we had I squared is equal to negative 1. So there's a little connection to the real numbers now. Negative 1 is a real number. I squared is a complex number And what we can do now is write this as negative 1. Well, the square root of r squared is simply r. So this is negative 1r, or you can just write it without the 1 involved, like that. Okay, well, that's a couple properties. I'm kind of bored so far. I mean, let's see more cool stuff. Okay, there's another example. All right, well, let's see how we use this to solve equations. Okay, so you just solve equations like you normally would. I mean, I think most of us, like on the previous section as well, in 1.5, when we're dealing with square roots, we would just simply subtract 11. Subtract 11 here. And this would give us 2x squared is equal to negative 48. That's right, 48. Yeah. Well, then what we would do is divide by 2. Divide this side by 2. So we'll get x squared is equal to negative 24. Okay? And now what we do is a square root here and a square root here. And since they're solving for a variable, we do need to put in the plus or minus. So we'd have a plus and minus right here. And so we get x is equal to plus or minus. Now, what I would do, since there's a negative, I'd rewrite this. How about we rewrite it as negative 1? Now, I'm also looking for some perfect squares. And I think there's a perfect square in there because isn't that 4 times 6? You see? And 4 is a perfect square. So I'd also write this as the square root of 4 times the square root of 6. Now let's simplify things a little bit. The square root of negative 1, this portion right here, is I. And the plus or minus. The square root of 4 is 2. And the square root of 6 does not simplify any further. There's no perfect squares in there, so we just write that as the square root of 6. And so we have x equals 2i times the square root of 6. Okay, so I think what I'll do is stop for a moment because you have on your study guide 3 problems you can do now. How about if you do the first 3 problems on your study guide, and I'll give you about 5 minutes to do the first 3, okay? So I'm going to pause the lesson. Okay, so let's look at number 3. First thing we want to do, thing always has a hard time flipping. Okay, so the first thing I would do is move this 5. So I'm going to add 5. Add 5 here, right? I'm going to write this as 4x squared is equal to what? Negative 72? Huh? Yeah, I'm doing number 3. And then I'm going to divide by 4 here and divide by 4 here. X squared is equal to negative 18. Okay, so now I want to take a square root here and a square root here. Now this is a square root of a squared number, so it's just simply x. And over here I'm going to have a plus or minus, alright? And there's a negative 1 in there, right? So I'm going to write this as plus or minus the square root of negative 1 times the square root of 9 times the square root of 2. Now why did I use those numbers? Because 2 times 9 is 18, but I could have used 6 and 3, right? So why did I use 9 and 2? Yeah, because 9 is a perfect square. So this is going to simplify. So I'm going to rewrite this one as plus or minus 3. Now what's the square root of negative 1? You should know now by. That one's I. And then you have the square root 2. Now, just so you know, normally you'll write a number in front of an I. Like when you first looked at this, you probably said, well, that's an I there, that's a 3, and that's a square root 2. That way of writing it looks a little complicated. It's not that it's complicated. This 3 we'd normally write in front of the I, that's all. Okay? So, how's that look? Everyone getting how this works so far? Alright, well, let's move on. So, we just did a couple of those. We did about 3 of them on your study guide. So let's move on. And let's learn how to add and subtract. Alright, so a little bit more about imaginary and complex numbers. A complex number is written in standard form. So, the way we do it is a complex number. It's complex because it has a real part and has an imaginary part. So the real part we always write first, and then we write the imaginary part second. Now, here's the thing then. Every real number can be written as a complex number. Like 7. 7 is a real number, right? Well, if we wanted to write 7 as a complex number, we could write it like this. 7 plus 0, I. You see? So, here's the thing though. Not all complex numbers can be written as a real number. And so the complex numbers is the biggest number set that we have. Because every real number could be written as a complex number. It simply goes in as the real part. Okay? So, complex numbers have situations where, well, we have a combination of these, like 2 minus 5i, for example. There's a complex number. Because it has a real part and an imaginary part. And so that's why we call it complex. It's not that complex though. Anyhow, what we're going to see next is how to add these things. And the way you add them is you keep the real parts together and you keep the imaginary parts together and you just add them like terms. Like you know how to write, if I were to ask you for 2x plus 3x, hopefully you guys would all be saying 5x, right? Well, the same thing works here. It's just the real parts and the imaginary parts are separate, and you just can add them. Like, by the way, do we need parentheses in this situation? Oh, we have a plus sign right there. So this is really the same thing as 8 minus I plus 5 plus 4i. 4i. Now, the real parts we add together. 8 plus 5 is 13. Minus 1i plus 4i is plus 3i. And that's it. You cannot, we don't want to go any further. The imaginary parts do not combine with the real parts. You need to keep them separate.
That's all you do.
That's all you do. You see how easy this is? So you always write the real part first, and then you write the imaginary part. Okay? The real part comes first. Imaginary part comes second. I'll bet most of you could do number or letter B here by yourself. Oh, but there is a negative here, so be careful. The negative needs to distribute first. Think of it as a negative 1 out in front. So you have 7 minus 6i.
I would just say it's I.
Huh?
I would just say the negative 1's I.
No, because negative 1 is not I. It's the square root of negative 1 that equals I. Okay? So, be careful. This is minus 3 and then plus 6i if you distribute the negative 1. Now you can add the real parts and you get 4, and you can add the imaginary parts.
Yeah, I.
Oh, no, you don't get anything because minus 6i plus 6i is 0.
Yeah, you find it.
Oh, so you just leave your answer like this.
I.
Now, if you really wanted to, you could write it as 4 plus 0 I. But this is, of course, 0i is It means there's nothing for the imaginary part. And so you're going to have a couple of these also on your study guide where you just have to simplify things a little bit. How about if you go ahead and do numbers 4 and 5 now on your study guide? Okay? So go back to your study guide and do numbers 4 and 5. Okay? I'll give you like 2 minutes to do that one. And once again, I'll just pause.